In the previous video, we covered the entire simple linked list, and in this video, we are going to start with circular singly linked list. And the concept is entirely same. And let's understand the major difference. So, as you guys know, like linked lists are formed by nodes. When multiple nodes are connected, then we call it as a linked list. Each node contains two main components, that is a value and an edge. Value can be anything. If we want to store like it can be my name as well, and the edge will be storing the address of the node it is connected to. So over here, if you want to see if A is the value of the first node and B is the value of the second node, then the edge of A will be storing the address of the node B. So let's start with the major difference of the circular singly linked list. Initially, what the major difference is? Initially in the singly linked list, what we used to do is the last node was pointing towards none. But now, as you know from the name, it is circular, so the last node will be pointing towards the first node. And for example, like where it has been used, suppose we have a Spotify playlist, we had a lot of, you can say, songs in it, but after listening to all of them, you are at the last song, and once the last song has been played, it again resets or again starts playing the first song. This is where circular linked list has been used. So let's start with our first method, and that is append. Initially, if the linked list is empty, we will be doing something like this. Initial node, let's call it node A. Then our head pointers and the tail pointer will be pointing towards node A, and the last, we can say the next will also be pointing towards the first one. Like if there is a single song in the playlist, it keeps repeating itself again and again. Now, suppose if there is an entire linked list, we have multiple songs, then we want to add a new song in the end. What we'll do is initially we'll create a node, we will take it to the last node. Now, what happens is the previous last node or the tail node will now be pointing towards this new node. The circular path, or you can say the connection between the last node and the first node, will be severed. And as you know, like once this node is connected, the last node, which is the new node, will be now pointing towards the first node or the head node, and the tail pointer will now be shifted from the previously last node towards the new node. So now let's start coding this and let's see how it works. Initially, we'll start with our node class, which we already did in the previous video as well. So we will create an initialization function. And this will be taking a value, which is the value of the node. And now this will be equals to value. And what next? That is the next pointer or the edge will be none. Now we'll create a circular necklace class. And we'll be creating an initialization function over here as well. And this initialization function will not take any value since we are creating an empty circular single necklace first. So what we'll do is self.head is equals to none. Now self.tail will also be none. And self.length, that is the count of the linked list or the length of the linked list, will start from 0. Now, what we'll do is we'll initially print a str function. What it basically does is every time a linked list or the linked list element is called, or if we want to print an entire linked list, this is what it will follow. If we do not use this function, what happens is it will just print a random address from the linked list or the head address to be specific. And if we use this function, it will print the entire linked list. And you can see how it goes. Initially, we'll create a result variable which will be storing something like this. Is equal to, we'll be creating a temp node and we will be pointing it towards our head of the linked list. Now, the reason we are creating the temp node over here is if we move our head pointer, let's see over here, if we move our head pointer from here to here, or anywhere else, we will lose the point where the linked list is initiated or well it is starting. So it is better to use a temp node, or you can say a node which we will be using for traversing the linked list. So now what we'll do is while temp node is not none, we will plus equal, we will input our values to it. And if temp node equals to self.tail, that is if we have reached the end of our linked list, and what we'll do is we'll directly return the result. Or and if it is not, but if temp node dot next is not null, or if the next node has a value, what we'll do is we'll add a edge so it is easier to visualize. Now temp node will be pointed towards the next node. Node dot next, and at the end, result. Now let's move on to the append method. And I hope this function is clear. We have already covered this function in the previous lecture as well. So if there is any doubt, you can let me know. And now let's move on to our append function. Where we'll start with append. It will take a value for the node. What will first do is will initialize a new node, which will use the class which we had created for node, and will add a value to it. So the node gets initialized. Now, if self dot length is equal to 0, or if the linked list is not yet been created, what we'll do is self dot head is equal to new node. So we'll point the head towards our initial node, and we'll also point tail to the initial node. And as I mentioned, like this wasn't in our previous lecture because it was a single linked list. And here, since we have circular single linked list, what we'll need to do is this node will also point towards itself as it is circular. So new node dot next will be pointing towards new node as well. Now, if already we have a linked list which is already been created with multiple nodes, then what we'll do is self dot tail dot next, or you can say the last element will now point towards new node. Then new node dot next will point towards our initial node as it is the last node. It should be returning towards, or you can say moving towards the first node. And now we'll move the tail pointer towards the new node. Self dot tail is equals to new node, and at the end we'll increase the length of our linked list. That is just equals 1. Now let's test this out if it is working or not. So let's create an envar variable. So we'll do it like this, circular single linked list, which will be taking this class, and we'll call the append method to this. And now we have entered all the values. Let's print our linked list. Let's save it, and we'll go here and type in circular single linked list. And here you go. We have appended successfully. We have our, as you can see, we have appended numerical or in an ascending way. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. We have this over here. Now we have successfully completed our append method, and now we'll move to our next method that is called as prepend. So let's understand how the concept works over here. Initially, we have our new node which we want to add to the start of our linked list. So let's call the old node as A. Increase the size, and our new node as C, and our end node as B. So what will happen is initially we'll start with a new node, that is C node will start pointing towards A. We'll shift the head counter from A towards C. So this gets, or this becomes our new head node. And then what happens is initially we was pointing towards A as it was our original head, or you can say the starting point of our linked list. But now it will change. Now B will be pointing towards our C node. So our prepend is completed, and now what we'll do is we'll start with the coding process, and let's create a function over here for prepend that will also take self value. And let's start. Now we'll create our new node or initialize a new node, which will be node, and it will take the value which we have sent it. Now we'll check if self dot head is none. Okay, by the way, this line, if self dot head is none and if length is equals to 0, is checking the same thing. If the length is 0, then you can say the linked list has not yet been created, and if the head is pointing towards none, then the linked list doesn't exist as well. So this is fine. I have written both the methods so that you guys don't get confused, or you know the alternate option. We can also do over here is we can change the head to tail as well. So if tail is pointing towards none, then it is like linked list is initially empty. What we'll do is if the linked list is empty, self dot head is equals to new node as the same thing. Self dot tail will also be equal to new node. Now new node which we initialize dot next will also be pointing towards itself. That is the new node. And if this is not the case, then we'll move on to our next method. And what we'll initially do over here is we will check self dot tail dot next, which will be adding pointing towards the new node, which we said like initially the tail was pointing towards our A. Over here, if you can see, it was originally pointing towards this node. Now it will point towards our new node. So once the new node is ready, we'll do what we'll do next is new node dot next will be pointing towards head, and now self dot head will be pointing towards our new node. And we have completed the adding. Let's add update the length parameter plus equals 1. Now let's test it out. PS dot prepend, and will be prepending 0. Let's see if it is working. And as you can see, we have completed this method as well. Let's move on to our next method that will be insert at a particular index. So before starting or coding it, let's understand how it will work. Initially, let's suppose we want to add a new node towards like the fs or the index of f. What we'll initially do is we'll start traversing our linked list from, you can say C, we'll move to A, and we'll move to D. What happens is over here, if we want to add our new node over here, we'll need to change the node or the previous node to point towards our new node. As you can see, if we traverse towards our, you can say, the node which we want to change, we have no place to, you can say, go back to the previous node. So initially what happens is this node connection will be severed. Now this node will be pointing towards here, E, and then E will be pointing towards the new node, and this is how we'll be inserting node at any given index. So let's start coding this function. And what we'll do is insert at index, and what it will take is then comma, it will take value and the index which where we want to insert it. Now over here we'll initialize new node as we did for all previous ones. Now node will take value and then put self dot head is none. Then will, or you can say index is equals to 0, will directly input it towards the start of our linked list. Now over here, what happens is if the index is 0, then we'll move to append, and if the head is none, then we'll need to create a new linked list. Then since there is no linked list present, what we can do here over here as well is we can, if it is none, we will be returning an error statement. It can be possible as not yet created, and if index is equals to 0, then we'll directly call this append method, which we have previously created. Let's make it insert. Now let's cover another scenario. Then another scenario could be the index is equals to center of length, or index is equals to -1. What we'll do is we'll directly append it towards the end. Append, and this will be our value here. So as if you know the concept of list, what we initially do is if we have a negative number, then we insert it or iterate over our list from the back, or we can say the end. And this is the concept we have implemented over here as well. If the index is -1, then we'll be, you can say, appending towards the end of our linked list. I won't be covering, you can say, the entire flow, but this is how it works because I am hoping that you already know this concepts of you can say list and dictionaries, etc. So what we'll do over here is else if index is less than 0, or you can say less than -1, we will return index out of 3. Let's cover the scenario as well. Or index is greater than self.length. So if the index is less than -1, then we will initially send index out of range. And if the index is greater than length of our original linked list, then it won't be possible to import it. So we'll send this. It is possible to cover this scenario. I hope you can do it yourself, or you can consider it as a homework. I have already learned that, and if I import it over here, or if I teach you over here, it will increase the time of our video. So now, at the edge case, or at the end, what we'll do is temp node will be equal to self.height. And if you guys want this, or if you guys want me to cover the negative scenario, then you can tell me in the comments. I'll cover it in my next video, since we have a lot of, you can say, 2 more topics for the linked list part. Yeah. Now let's move on to a code in the range of index -1. What we'll do is temp node is equals to temp node dot next. And now, since we are at the node which we want to add, we'll see next temp node next. So initially what we did here is new node which we had created will be now pointing towards the node which we had, which we want, or you can say at the index where we want to add. So what happens is we have now imported it, or you can say our new node is pointing towards the old node over here. It is now pointing towards F, is pointing towards F. And now what we'll do is temp node will now point towards our new node. And we'll increase the length of our linked list. Self dot length plus equals 1. And this is how we are adding to our circular linked list. And the next what we'll do is I have already covered the traverser over here. Like we will be wasting time if I create a function for traversing. So what we'll do is we'll create a next function for searching our linked list, or searching a particular value inside our linked list. And how we'll do is we'll traverse our linked list one by one over here, and we'll match. We'll start from head. We'll move to C, A, D, E, F, and etc. Suppose we want to find the value of let me send it to Z. So what we'll do is we'll initially start from head. We'll move to C, A, D, E, S, and let's make it S, and then we'll move to Z. We'll compare the value, and if the value matches, we'll be returning true, and or else we'll be returning false. So let's move on towards the coding part. Or yeah, we also haven't tested it, right? We'll move on to the testing part. This function dot print, and we'll be inserting at 5, value 5, and at the location of 6. Let's see if it is working, and let's compare it. 0, 1, 2, 3, 4, 5, and 6. At 6, we have already, like you can see, we have added. And if we want to check over here, what we can do is after creation, we can print it twice. So if you see over here, we have already inserted, we already had 6 at the value of 6. Now it is 5 and 6 has been moved forward. So we can say the insert was successfully done. And now let's move on to our next function, that is search value in single linked list. This will take string and it will take the value which we want to search. So what we'll do is temp node will be initialized, like dot head, and we'll also create an index. So we can know while temp node is not null, what we'll do is if temp node dot value is equals to the value which we want to search, then we'll directly can say return. So let's print a statement as well. That will be useful for debugging or answering. So we'll add a string over here. We'll print found value at index x. Okay. And now if this is not the case, and if temp node is equal to self dot tail, we will return false. Also, let's print a statement over here. We print found the value. And in the end, what we'll do is, if this is not the case, then we'll just extend or move on to the next one. Temp node dot next and increase the index return. Next plus equals 1. Now let's see using it. It should work. Dot this, and let's search for 4, and let's stop inserting this, and we'll not print multiple times as well. So you can see we have already found. Okay, this spelling mistake is. Yeah, but as you can see, basically it works. Now let's search for 100. Let's see if it is working. So as you can see, we did found the value 100. So it is working. Now as you can see, we have already implemented source, we have implemented insert, prepend, and append. Now we'll move on to the searching at a particular index. So we don't know if where is the value of what is the value of the node at a particular index, then this function will be useful. So let's start with that function. This is also simpler, like we will be doing the same thing. We will be iterating over each and every node until we reach our index node, and we'll directly print the value. You can see it is easier. And I hope like you are trying these functions or trying to write these functions by yourself, which will be useful because I myself learned the same way. Like once I got to any function, I initially tried it out myself if I was able to do. Even if it is, you can say highly time complexity. Like if the time complexity is more or the space complexity is more, at least try it out because this is that is the only way you will improve. If you just look at the functions and think like I already know them, then it won't help at all. So let's move. Link list is empty. Then we'll directly return list is empty, and if self dot length is less than index or index is less than 0, will return index out of range. Now we'll move on with the traversing. Now temp node will be pointing towards the head, self dot head. Okay, let's get some space over here. And now for 4 and 3, 0 comma index plus 1 with 1. And what we'll do is temp node is equals to temp node dot next. And at the end, what we'll do is return temp node dot value. Now let's test this function out. We'll see SLL dot, and what we'll do is let's search for index at, we'll search for 5 million. So let's see what happens. Let's see, let's type error, then type in variable. So let's see what happened. Initially, self dot head in. Okay, over here we have made a mistake. Is done. And let's see again. It should work now. And yeah, we need to print. Okay. And as you can see, we got 6 over here. Yes, we have incremented. Okay, the index is starting from 0, correct? So we won't need this. Let's see. And as you can see, for 5, we are getting 5 only. This is correct. So what we'll do now is after we have done this, we will create a function which is going to be used for updating a value at a particular index. So what happens is if we want to update this value, we want to make it 4 to 400, what we'll do is we'll create this function and it will do that specific thing. Update value at index and it will take self index and the value which we need to update and we'll check if this dot head is none. Then we'll say return else if else if index is greater than self dot length or index is less than 0, what we'll do is return index out of range as now. We'll finally move on to the editing part. Now we'll check temp node is equal to self dot head and for in range till index. What we'll do is move on to the next node, temp node dot next. And then when we reach the value or the node intended, we'll update the value as value over here, which we have taken in. Now let's test this function out as well. Let me copy it over here into this, or let me comment this out. Again, try to and we had initially kept it as index and value. So let's update 4 with 400. Let's see if it is working, and it didn't work. So it just updated the initial one. So let's see where we went wrong. So in the range, okay, we have in range 8. That's right. I have a lot of typos. Let's see if it is working. Yeah, and it worked well. Now what we'll do is we'll start with our new method or removing a node. So as you can see, we'll start with pop first. That is, we will be removing this node over here. And what happened over here is if we remove this node, the last node which is pointing towards C will be then started pointing towards the A. And this node which we have is will be deleted. The head pointer will be updated over here. It will be updated and start pointing towards A. So let's start with coding it. Left and we'll name it pop first. And it will be self over here. And we'll see if the linked list is empty, we'll directly return none. Is none, then return is empty. And if it is not, then what we'll do is pop node will be equal to the head as we are removing the first node from the one linked list. Now this dot head is equal to self dot tail. And this is the check where we will see if the linked list only has one value. Then if it is only having one value, we'll be directly making head as none and self dot tail will also be none and it will be removed. And if this is not the case, what we'll do is self dot head is now pointing towards self dot head dot next, which means the next function or the next node from the start. So initially we had C over here. So now that C has been removed. So head is moving from C towards A. And then we'll move the tail pointer or tail's next pointer, tail dot next. It was initially pointing towards C, towards the start. So it is dot next. And then what we'll do is pop node dot next, which was initially pointing towards something, will now point towards none, and then at the end we'll update the length counter, which is minus equal to 1, and then we'll return the pop node. Let's see using it. Let's copy this. Now let's ln pop first. Before that, let's print so we can directly see the difference from the start. As you can see, initially we had 0 as the first node, and now it's 1. We have successfully popped our node. And after this, we will work with popping the last node, or you can say removing the end of the node. As you can see, we had implemented the you can say append method, and then we had implemented the prepend method, and then we moved to the insert at any you can say index. Now, similarly, we will be going from pop first to popping the end one, or just the pop method, and then we'll move to the remove method. So, how this will work is initially this node, the tail pointer will move over here, which is from B. It will be moving towards Z, and this pointing will be removed towards our first node, which is A, and this pointer will be as well. So this is how our linked list will look like after you can say we have used the pop method. So let's start coding and see self self dot head is none will return none. Now let's move on to the pop node. This will be self dot tail. As we know, we are removing the last node, and self dot head is equal to self dot tail, which means we only have one value in our linked list. Then we'll directly make self dot head, which is equal to none, and self dot tail will also be equal to none. If this is not the case, then what we'll do is we will create a temp node, which will be self dot head, and then we'll traverse that until we reach a node which is previous than the last one. Then what we'll do is temp my temp node dot next is not equal to self dot head. Then we'll directly increase the counter, or we'll move to keep on moving towards next node dot next. Now once we have moved to the second last node, what we'll do is temp node dot next will be pointing towards the head, self dot head, that is our first node, and self dot tail will now be pointing towards our new temp node. And in the end, we'll remove the pop node. So pop node dot next will now be done, and we'll remove or reduce the length of our linkers, that is minus equals 1. Now we had done that over here. Yeah. At the end, we'll return our pop node. Now let's see if this method is working. And we'll go over here, remove the this and then pop. As you can see, it worked. We had 9 as the last node, now we have 8. And now let's move on to our last method, that is remove a particular node or at a particular index. So what happens over here is if we want to remove key, when traverse towards you can say the D node, we will directly start pointing or we will point our D node from here to here, and this node will be removed. And this is how you can say remove a node at a particular index. So let's start coding and over here fill from index. And what we'll do is if self dot head is none, then we'll return none. As you can know, if the linked list is not present, then there is no point in doing anything. So now self dot length is less than index, or you can say index is less than -1. What we'll do is return index out of range error. Index out of range error, and then we'll see if index is equal to -1 or index is equal to self dot length -1. Now, why we have added -1 over here is because initially our index starts from 0 and it goes till the end, but the counter starts from 1. So the length of you can say over here, we could also add this -1 over here. So what happens is initially we won't get any errors. So if we are at the last node, we can do this, and what we'll do is return self dot pop. So we are removing the last node, and else if index is equals to 0, that is our first one, then we'll directly remove use our pop first function which we have created. That will go, and at the end, what we'll do is create a temp node as we have always done. That will be pointing it towards the right. Let's go and range -1. Temp node is equals to temp node dot next. Now, once we have reached our desired node, what we'll do is node remove will be now temp node dot next, and temp node dot next will now be pointing towards the next dot next next. So what is happening over here is we are directly pointing the node from D to F, and we are removing the connection from E over here. So instead of E in between, we are directly pointing it towards F. Once we have done that, what we'll do is node remove dot next, which will be none, and self dot length, which will be minus one, and then now let's test this out. Remove. I'll comment this part. ll dot remove, and we'll remove the index at. Let's see if that is working. And as you can see, we have successfully removed the number 4000 at an index of 400 at an index of 4. Now let's move on to the last one. I hope I don't need to explain this much, as it is the last, or you can say delete function. Delete entire linked list. What it will basically do is if self head is already done, then will return already empty. Else self dot head is equals to none, and self dot tail is equals to none. So what this basically did is we directly remove the, you could say, connection between the linked list. Also we'll be removing this as well. Self dot tail dot next is equals to none as well, as we had a circular pointer pointing towards side. So if you don't write this, it won't make much of a difference because we have already removed the connection and pointed this to none, so it won't make that much of a difference. But it is good practice to, you can say, remove any connection from the linked list. So let's test this function out, and we'll be done with this video. And let me comment this. I'll add this colon. Let's print it out. Let's see. And as you can see, we have successfully deleted our linked list. And this was all for this video. And if you find any part difficult, or if you have any solutions, do let me know in the comment section, and I will be surely improving on it.